Chuck's in it.
Yeah, I saw Chuck was in it, so, yeah. All right, so this problem is different. This problem is different because it requires the chain rule, but it also requires another rule. Anybody know what other rule it's going to require?
Product rule.
Product rule. As you read it, it says 2x times 4 minus x to the fourth. You see that? So we have two functions that are multiplying each other. So therefore, I have f prime of x is going to be equal to, I have function f, I have function g. Remember, the product rule is f prime g plus g prime f. So the derivative of 2x is 2 times the 4 minus x to the fourth power. Hey, that part was pretty easy, wasn't it? Plus, and this is where I'm going to show you guys something that I tend to do. You have f prime g plus g prime f. Everybody agree that's the same thing as f prime g plus f g prime? Like, you could switch the g prime and the f around, right? So a lot of times I just go ahead and write f in that situation. F is 2x. And now I need the derivative of g. And the derivative of g is going to require which rule? The chain rule. So let's go ahead and do the chain rule in that scenario. I like to grab my boxes, and I go u to the fourth, and I go 4 minus x. What's the derivative of 4 minus x? Negative 1. And the derivative of u to the fourth is 4u to the third. And so as you multiply these together, you can see that it is going to be negative, isn't it? So I'll just write times a negative 4 times 4 minus x to the third power. Now, in the last unit, I didn't ask you guys to simplify these difficult algebraic expressions. In this situation, anytime you're asked to use the product rule in conjunction with the chain rule, you have to simplify it. I'll show you how it works out. 2 times 4 minus x to the fourth power. This is going to end up being a minus 8x times 4 minus x to the third power. And the AP exam and a lot of books and a lot of professors, they want this written in a different fashion. And here's how they want it written. These will always have a common factor. What's the common factor among 2 and 8? 2. What's the common factor among 4 minus x to the fourth and 4 minus x to the third? They both share 4 minus x to the third power. So that's the common factor I'm taking out. If you take a 2 times 4 minus x to the third power out of this, what's left?
4 minus x.
Just 4 minus x. Just going to write it like that. I'll try to use colors so we can see exactly what's going on. Then we have a subtraction sign. And if you take a 2 times 4 minus x cubed out of this, what's left?
4x.
Just 4x.
Again, so where did you look to get the first one?
So what I did is I identified this as the common factor. And when I take this out of that, notice the 2 is gone, but I have 1 of the 4 minus x's left. Right? Because this times that creates the fourth power. And now when I take this out of that, well, 2 times what is 8x? 4x. And I have all of the 4 minus x cubes out here. Now, what's neat about this that's different for you guys that we haven't done before is as you look at this factoring, we can combine some like terms here. Notice I have a positive 4, and then I have a negative x minus 4x, which is minus 5x. So notice the result is written in complete factored form. And that's what I'll be asking you to do. Slightly more difficult? Agreed? Yeah. Okay.
Are you supposed to distribute the 2?
You can, just like Kira was asking before, if you want to take 2 times this 4 and 2 times the 5, you can. You don't have to. It'll be up to you in that scenario. But notice that these are 3 things that are multiplied together. I don't have any addition in between, and that's what I would want in that scenario. Okay? All right. Next one. Again, we're gonna spend about 3 days going over some of these harder problems. So today, Monday and Tuesday, test is on Friday, test is on Friday. This one is tough for the students. I'll do my best to help you see what's going on. If I don't do a good job explaining, please tell me. It says sine squared of 3x. What that means is sine of 3x, and it's that quantity squared. That's what it means. Okay?
So it's all together?
Yep. And so what I think is important for students is to understand the order of operation. And that's the key for the setup, is the order of operation. So I'm going to say this multiple times, but those who are able to catch on quickly, you're going to be better off for it, okay? This requires the chain rule, but let's see how we set up the structure. If I plug in something for x, the first thing I do is I multiply it by 3, right? What do you do after multiplying by 3? You then apply the sign to it, and after you apply the sign to it, you then square it. So everybody agrees that squaring is the last operation I did. So that's the first thing I have to set up, is u squared.
So the squared is over all of it, even though the squared is only behind the sign in the problem?
That's what that means. I'm squaring the operation of sine. So I take something, multiply it by 3, I then take the sine, and then I square that sine operation. That's what it means. So it's the last thing I do. So notice in the previous examples, I've always really talked first about like, hey, what's on the inside? It's easy to see the inside right away, right? Well, sometimes you need to think about, say, what's on the outside structure, okay? And it's u squared. So what's on the inside? Sine of 3x. What's the derivative of u squared? 2u. What's the derivative of sine of 3x? What? Close. No.
3x cosine.
3x cosine. Why?
Because the thing goes up front.
Yeah. So this is another chain rule situation, okay? So this is just a double chain rule problem. We'll get to triple chain rule situations. But notice in this scenario, if you want to find the derivative of sine of 3x, didn't we use the chain rule for that yesterday, where we said 3x was on the inside and sine of u was on the outside? That's what we're looking at. And so the derivative of 3x is 3, and the derivative of sine is cosine.
So you have to do 2.
Yep, it's a double chain rule situation. So this derivative here results from this derivative here. And if you multiply these together, you get 3 cosine of 3x. So as Andrew said, the derivative of sine of 3x is not cosine of 3x. It's 3 times cosine of 3x. I have to think about what's happening on the inside as well as the outside. Now I could take those and multiply them together. 2 times 3 is 6. I can plug the sine of 3x in for u, and I get the sine of 3x. And then I still have the cosine of 3x. And that is the double chain rule for sine squared.
You don't put the...
The 2 times the 3. Okay. Good work. Cross off this one for good measure. I'd like you right now, try letter B. Nothing funky with letter B, just a good old one-time chain rule. But to get the practice.
Wait. It's just the 1/3. Use it up. Fair power. No, not third root. It's square root. 4x. Is that there? Hold up. Yeah.
So then write your inside and your outside.
Grab it.
Get that? So when I deal with this situation, and to get to Laney's point from earlier, she talked about, do you substitute it in or do you multiply first? Watch how I'll do this. I'll substitute later. This is 1 over 3 u to the positive 2/3 then, because I drop it to the denominator, times -4 over 1. Sorry about that. So you get a -4 over 3u, and what is u? U is 7 minus 4x, then raised to the 2/3 power.
Is it bad if we wrote that as?
The cubed root of that squared?
Yeah.
That's absolutely fine too. But I will always raise a rational exponent. All right. Okay, flip it.
Yeah, so I got a question. So, here, remove this to the bottom, right?
Yep.
And the 3's down there,
Yep.
so then, we plug in this,
I'll plug in that. So I've got -1 over 3, and it's u to the 2/3, right?
Yeah.
And times a -4 over 1. So you see you get a -4 on top.
Yeah.
Then 3u, u's going to be 7 minus 4x.
so then you just plug that in.
Yep, you just plug it in.
We're supposed to get involved for her birthday.
Okay, we are going to do 2 more problems. I'm going to set you to your worksheet, and then we'll fill up the rest on Monday and Tuesday, okay? You guys are at a good spot, but we do have a couple more challenging problems to get. Letter D is an excellent problem. Talk to the person next to you. How would you go about taking this derivative? What would be your strategy? Go ahead. Don't try to actually take it, but what would you do?
Actually, you can shitting away. Just one of them. Just one of them. Just split. Maybe made my other cats run away. Did one of them impregnate.
You would not need to impregnate a cat in order to do this problem. It's going to end up on YouTube, but that's all right. But you do need to use what rule? We're going to have to use the chain rule how many times? Just twice. But let's think about the order of operation. If you were to plug something for x, you would add 2 and then take it to the 5th. You would plug something for x, you would multiply by 3, subtract 8, take it to the 7th. And at the very end, you would then multiply them together. So if multiplying those 2 expressions together is the last thing you do, then the first thing we set up is the product rule, without a doubt. This is a product rule problem. This is F, and this is G. I'm going to go ahead and set my work off to the side over here because we don't need to do that problem. You guys already know how to do it. Okay? And you guys, without a doubt, when I cross stuff off, that's something where when I cross it off, it's different every year. I read the group and say, do we need that? Do we not? Do we need that? Do we not? It's a lot easier to cross stuff off than to add stuff in. So we don't need that. You guys are good. This piece right here, I'm going to have the boxes, and I will have the boxes. So I'm going to calculate both those derivatives right now. And I'm going to first have u to the 5th and an x plus 2. So we'll do that first derivative. Derivative x plus 2 is 1. And the derivative 5, or u to the 5th is
5 to the 4.
So it turns out that this derivative is just simply 5 times x plus 2 raised to the 4th power. Are we okay with that first derivative? I can see I'm going to need the chain rule twice, so I'm going to just get my chain rule done with over here. Got my boxes, that helps keep me organized. I've got u to the 7th. I've got 3x minus 8. Derivative 3x minus 8 is 3. And derivative u to the 7th is
7u to the 6.
7u to the 6. And then we multiply them together, and the derivative would be 21 times, wow, man, I got some bad problems here for you guys, 3x minus 8 to the 6th. Got rid of
Why
that.
is this a bad problem?
Well, it's 7u to the 6th. I mean, I just walked right into the 6-7 world right there. It's like,
Nobody was even thinking
you know.
about that.
Yeah, oh, he did. They did. Oh, yeah. I can see out of this part of my eye, it's called peripheral vision. And it's like, as soon as I glance over there, I start to see the hands move just a little bit, you know? It's like, and then he covers his head with his yeah, there you go. Yeah. You know it, Andrew. Okay, so here we go. The derivative is going to be, okay, gotta be very careful here, because this is a tough problem. We're going to have the derivative of that, which is 5 times x plus 2 to the 4th. Then what?
3x
Times 3x minus 8 to the 7.
3x minus 8 to the 7th. Plus, this is a point where I like to just put f instead of g prime right away. So I'm going to write f, which is x plus 2 to the 5th. And then what goes next?
21.
Yeah, times that 21, 3x minus 8 to the 6th power. Now I've helped you guys out here once already. We're gonna do our best here to write this in factored form and help you see it. F prime of x is equal to, I'm gonna underline 1 in red and 1 in green. Tell me, what is the common factor between 5 and 21? Really isn't, so we just got to let that go. What's the common factor between x plus 2 to the 4th and x plus 2 to the 5th? So take out that x plus 2 to the 4th.
And so you have to compare both of them.
Yep. Notice this is one term, that's one term. When I say term, it's something that is all multiplied together. It is separated by addition, which makes the red term and the green term.
But so you're just comparing the 5x plus 2 to the 4th?
Yeah, well, I'm comparing the constants, so 5 and 21. I'm comparing the x plus 2 to the 4th, x plus 2 to the 5th, and then I'm comparing 3x minus 8 to the 7th and 3x minus 8 to the 6th. And they both share in common a?
3x minus 8 to the 6.
Good. Times whatever remains as we take out that common factor. And from the red, if I take out x plus 2 to the 4th and 3x minus 8 to the 6th, what remains?
5 times 3x minus 8.
What do I write now? Plus 21
X plus 2.
x plus 2. So this is that nice factor that we took out. F prime of x is equal to x plus 2 to the 4th, 3x minus 8 to the 6th. And then we need to combine some terms here. And watch how nicely this works out. 5 times 3x is 15x, and I'm going to add that to 21x, which makes 36x. I have 5 times negative 8, which is negative 40, plus 42, which is dos, which is Spanish for 2. Now, I suppose you could factor out a 2 out of that if you wanted to as well, to have an 18x plus 1, but you don't have to. But notice this is written in factored form, which is really nice. When it's written in factored form, it's easy to graph. That's an 11th degree polynomial. We could sketch a graph if we wanted to, and be able to compare the derivatives that way. So, good job. Go to your homework.